Hey, welcome to Jed Foster Maths. In this video, we're going to be looking at integration by partial fractions. This is the next part in the integral series that we've been going through on the channel. So in this one, we're going to be looking at when you know you need to use integration by partial fractions, how you can spot when you need to use this technique, and obviously how to do it. So let's start, and I'll show you an example. And this is a classic example of when you need to use integration by partial fractions. Okay, so let's say you were given the integral of 3x plus 11 and then divided by x squared minus x minus 6 with respect to x. The giveaway that we need to use by partial fractions is because the denominator can be split up into two products. And in this case, it is a quadratic. But again, this applies to many different things. If you have a cubic, basically, if you can split the denominator up into more than one product, then we're going to be using by partial fractions. This is the same for, let's say you had x squared minus 4. You know that is going to be a difference of two squares, two different products. Again, that's the giveaways. And it can get more complicated, but we're just going to be looking at some kind of introduction level questions to this. So now we know why we need to use by partial fractions, like when to use it. Let's start by step 1. Whenever using integration by partial fractions, you spot the integral, pull the denominator out, x squared minus x minus 6. By the way, before I go any further, just want to give credit to Paul's Online Maths. A lot of the problems in this video I'm going to be using from their website, so if you want to give those a go, just go to Paul's Online Maths. So I need to give credit where credit is due, so let's get on with the video. Okay, step 1, pull out the denominator. Step 2, we need to split this up into two different products. And that's because that's going to make it so we can actually integrate out of this question, because in the state it is right now, we can't really integrate it. So they're split up into two fractions that are equivalent to each other. And the way we do this is, step 1, we need to actually factorize the quadratic. And if you don't know how to do that, or it's been a long time, here's a quick refresher. By the way, this is my way of doing it. There's many different ways of factorizing quadratics, but I like this way the best, so I'll be showing you this method. So step 1, when you're factorizing a quadratic, write your a value, your first value in the quadratic, in that case x. We know x multiplied by x equals x squared. And if you had 3x squared, you just write 3x squared there. That's the idea. Just, you want a table, multiply these together to get x squared. And for our c value, minus 6, again, we want to get two factors that multiply to get minus 6. But the trick with this one is we also want to cross multiply and have the answer equal to minus 1x, which is our middle term, the b term. So you need to think carefully about what numbers you're going to choose. But I can see this is going to be minus 3 and 2, because 2 minus 3 is minus 1, and that's the giveaway. Whatever the coefficient is, just set your factors, so you multiply them, you get minus 6, you add them, you get minus 1x. And let's prove this. We'll have minus 3 times 2 equals minus 6, and multiply crossways, we're going to have 2x, and this time we're adding x times minus 3 minus 3x. 2x minus 3x is minus x minus 1x, or just minus x. So that's how you check these, and I think this is the best way of doing them. So next up, you simply just write it as you see it. Slap some brackets around your value. So you're going to have x minus 3 multiplied by x plus 2. And that is equivalent to x squared minus x minus 6. You multiply that out, you'll get the same answer. So we're just breaking this apart into more manageable parts so we can integrate this. That's all we're doing. Next up is where we actually start applying integration by partial fractions rule. And what this says is we need to, in this case, because we have two products, x minus 3 multiplied by x plus 2, we have two products. We want to introduce two variables. And the way I like to do this, and most people do it, is a and b. That's what we like to call them, but you can call your variables whatever you like. Just make sure it works for you. We're going to set a, our first variable. We're going to divide that by x minus 3 plus b divided by x plus 2. And set this equal to 0. Same process for every question like this. A little bit different for a cubic where you have 3 products, but it's all very similar and all pretty much the same. If you had a cubic, you'd just be adding in another variable. You'd have c, a, b, and c, and so on. If you had if you have 4 products, like whatever, you just keep adding the same number of variables in. And the next step, this is how I like to do it, is we're going to cross multiply. So we're going to have a multiplied by x plus 2 plus b multiplied by x minus 3 equals 0. And because we introduced a and b, we're going to be solving with respect to x. And pretty much all we're doing now is we're solving the two x values that this quadratic can take. So you can either go back to the original question and use the quadratic formula, or what I like to do is by the null factor law, because you've already gotten to this point here, so I find that's a lot more quicker and easier than typing into your calculator with the quadratic equation. So we know each bracket to satisfy the equation must be equal to 0. X is either going to be equal to minus 2, or x is going to be equal to 3, because that will make each bracket equal to 0. The reason we have two x values is because it is a quadratic, so that's why. And once we found the two x values, you're going to write it in this form. And by the way, because we have two x values, we're going to have two different equations that we're solving. But we're solving for a and b, which is our new variables that we have introduced. And the reason we're solving for those is to break the fraction up into multiple parts that we can integrate. So that's what we're doing. It's going to be equivalent, but we're just splitting it up. So that's all we're doing. I want you to understand this as well. It's very important. So step 1 for our first equation, we're going to set x equal to minus 2 and solve for a. When we're solving for an equivalent fraction broken into two parts, look at the denominator, 3x plus 11. So we're going to write this out. 3x plus 11 is going to be equal to this line of working right here. Our a and b value that we cross multiplied with the factorized quadratic. So that's going to be equal to a x plus 2 plus b multiplied by x minus 3. So that's the equation that you're going to be working with most of the time. Again, if you had multiple products, you'd be adding in another one, c. So this is the equation. This is the equation that we're going to use. And because we have two x values, all we're going to do is substitute each x value in and do the equation twice. That's going to solve both answers. So our first x value we got was minus 2. We're going to just substitute that in. 3 times minus 2 plus 11 equals a multiplied by minus 2 plus 2 plus b multiplied by minus 2 minus 3. That's the first equation. In the second one, you're just going to substitute x equals 3 in. That's all you're doing. And I like doing this. It saves you having to do it by simultaneous equations. But you can if you want. And this is the way that I like to solve these. So we're going to get minus 6 plus 11 equals, and you can see minus 2 plus 2, 0. So a goes to 0. So that's simply going to equal b minus 2 minus 3 is minus 5 That's going to be equal to minus 5 multiplied by b. And I like doing this because we can easily get rid of the a and solve for b, and then again with the second equation get rid of b and solve for a. I find it saves a lot of time and it's easier. It works for me. But if it doesn't work for you, just do it by using simultaneous equations or whatever you want to do, alright? We're going to have minus 5 we're going to have 5 equals minus 6 plus 11 is 5, minus 5b, divide by minus 5 on both sides. B is going to be equal to minus 1. And for our second equation, doing the exact same thing, but we're solving for a. So our next x value was 3. Substitute that in, 3 times 3 plus 11 equals a multiplied by 3 plus 2 plus b multiplied by 3 minus 3. So we're going to get 9 plus 11, we're going to get 20 equals 5a. 3 plus 2 is 5, multiplied by a is 5a. And for b, minus 3 minus 3, 0, b goes to 0. So it'll be plus 0, don't write that in, there's no need. And then we can solve for a. Divide by 5 on both sides. A is going to be equal to 4. And b is going to be equal to minus 1. So that's most of the hard work done. And now all we're going to do is we're going to substitute our a and b values back in to achieve a equivalent fraction. And this fraction we're actually going to be able to integrate. So I want you to go back in your working. Look at what we had written up first. A divided by x minus 3 plus b divided by x plus 2. So let's write that down. A divided by x plus 3 plus b divided by x minus 2. And keep in mind, we're going to be integrating this. So we've solved for a and b. A is 4. B is minus 1. And let's integrate this. So by knowledge of your integration laws, what we know is we're going to get 4. And by the way, if you don't know how to integrate these, just go back one of my previous videos, integration introduction. Give that a watch and I'll explain how to integrate these. Or you can find someone else who can explain it. We're going to be taking logs because it's being divided. So we're going to have 4 divided by natural log of x plus 3 minus 1. Minus 1 multiplied by natural log of x minus 2. And don't forget plus c. And that's the answer. That's our integral, f of x. We can get rid of the minus 1. You could probably tidy it up a little bit if you wanted to. Maybe divide them. But yeah, never mind. Just leave it like that. I'd say that's pretty good. And that's the answer to the first question. Okay, so let's move on to another one. And we're going to be doing the same process, but it's not going to be as obvious as a quadratic this time though. Let's say you had 5 divided by x squared minus 6. Okay. Let's just say we had x squared minus 1. This one should be pretty good. I want you to recognize that the denominator can be split into, by using the difference of 2 squares, we can split that into 2 different products that are equivalent. So let's do that. Again, we're going to take the denominator out, x squared minus 1. Going to be equal to x plus 1, x minus 1. And with the difference of 2 squares, you can just, one good way to do this is you look at it and you see that you can split it up into two parts, x plus 1, x minus 1. And when you multiply them together, the 1's going to cancel out, leaving you with a minus 1. And I'll prove it. We're going to have x squared minus x plus x, 1 times minus 1, x squared minus 1. But this is sometimes just a pattern you need to pick up. And if you're in an exam or something and you can't seem to figure out how to split it up, if you're allowed graphics calculators, it will do it for you. Just keep that in mind. But always try and spot when these the difference of two squares. So x plus 1 multiplied by x minus 1. Okay, so now we've solved this again. Let's introduce our two variables. We're going to have a, x plus 1 plus b, x minus 1 equal to 0. So same process, exact same formula for this one as we did the first one. So give the video a pause, try and do this one yourself, give it a go, and let's go. Again, we're going to cross multiply a multiplied by x minus 1 plus b, x plus 1 equals 0. Use our null factor law, x is going to be equal to 1, or x is going to be equal to minus 1. And that's going to satisfy the equation. Next up, again, we have two different x values. Put the numerator in. For our first equation, 5 equals, we're going to substitute both x values in, solve for a and b. 5 equals this, put x equals 1 in, 1 minus 1 plus, so that's a multiplied by 1 minus 1 plus b multiplied by 1 plus 1. 5 equals, a is going to go to 0, 1 minus 1 is 0, multiplied by a is 0, so that doesn't count. 5 equals 1 plus 1, 2 times b, 2b. b is going to be equal to 5 divided by 2 when we're dividing by both sides. And let's do the exact same thing, but with the second x value. So we're going to have x is equal to minus 1, 5 equals a, minus 1 plus b, minus 1 plus 1. Solve for a. 5 equals minus 2a. b is going to go to 0, minus 1 plus 1, 0. b is 0, minus 1, minus 2 times a, minus 2a. Divide by minus 2 on both sides, solve for a. a is going to be equal to minus 5 over 2. And b is going to be equal to 5 divided by 2. So now, again, same process. Let's rewrite the integral with our new equivalent fraction. So we had a divided by x plus 1 minus 5 on 2 divided by x plus 1 plus b is 5 on 2, and for b, x minus 1 dx. Okay, let's simplify this down a little bit. We're going to have minus 5 divided by 2 multiplied by x plus 1 plus 5 divided by 2 multiplied by x minus 1 with respect to x. And now we've got this, let's bring the constants out. It's going to make it a little easier to solve, although you could solve this just as it is, but let's take the constants out. And we can rewrite it equivalently, minus 5 divided by 2. We're taking the integral of 1 divided by x plus 1 dx. We're taking the integral of the other side as well, so we're just going to write it down as 5 divided by 2 multiplied by the integral of 1 divided by x minus 1. And that is with respect to x. Okay, so let's begin to solve this. We're going to have minus 5 over 2. That's the constant, so that's why we brought it out the front. You can do that in integration. Bring any constant out the front if you want to, doesn't matter. Can make it easier sometimes, but Whatever works for you, just go with that. Minus 5 divided by 2, the integral of 1 divided by x plus 1. From the integration laws, we can know that's just simply going to be ln x plus 1. And then again, the integral of the next integral, we're going to have plus 5 divided by 2. Natural log of x minus 1. And don't forget your plus c for your constant of integration. Sweet. We can take out 5 over 2, so let's simplify this down. 5 divided by 2. We're going to have ln x minus 1. And then we're going to have minus ln x plus 1 plus c. And you can simplify this down even further if you want to. Let's just do it. We're going to have 5 over 2. By the way, you don't have to. This is perfectly valid answer, so you can just leave it like that if you want. But if you know your log laws, you can do x minus 1 divided by x plus 1 plus c. And we'll leave it like that. Maybe you could go even further if you wanted to, but that's pretty good. So we're going to leave our integral like this. Okay, let's wrap the video up and let's do one more problem. So let's say you were presented with this, you were asked to integrate this. Let's say you had 6x divided by, I'm going to have x squared plus 14x plus 40 dx, and that's all divided by this. And let's add in some limits as well. Say we're integrating limits 5 and 1. Okay, so again, forget about the limits. Let's just integrate this first, just like what we've been doing before. So treat this like an indefinite integral. Let's integrate this. So again, step 1, pull out the denominator, x squared plus 14x plus 40. Write down your table, x times x squared. And we want to find two numbers that multiply to get 40, but add to get 14. I am thinking of 10 and 4. 10 times 4 is 40. 10 plus 4 is 14. And sometimes it can be more complicated and you have to think about these a little more, but play around with it until you get the right numbers. So again, we'll just prove it anyway. 10 times 4 equals 40. And then we'll cross multiply 4x plus 10x equals 14x. So that just kind of proves that this is correct. So write this down as a product, x plus 10, x plus 4. Again, we have two products, two variables, a and b. That's what I'm going to set them to. So a divided by x plus 10, same process, plus b divided by x plus 4. I'm going to set that equal to 0. So again, let's cross multiply. We're going to have b multiplied by x plus 10 plus a multiplied by x plus 4 equals 0. And because we're solving with respect to x again, use the null factor law, find both x values that satisfy the quadratic. X is going to be equal to, make this bracket 0 minus 10, or x to make the bracket of a equal to 0 is going to equal minus 4. So we've solved for both our x values. And we've got this equation right here. And again, we can see the numerator 6x. So we're going to have two equations. We're solving with both x values that we've solved. 6x equals b x plus 10 plus a x plus 4 equals 0. And so we're going to do this twice with both x values. So for x is equal to minus 10, 6 times minus 10, substitute x in, equals b minus 10 plus 10 plus a minus 10 plus 4. Negative 60, going to be equal to, b is 0, minus 10 plus 10, 0. So we're going to have a minus 10 plus 4 is negative 6. So we're going to have equals negative 6a. And let's solve this. We're going to have a is going to be equal to 10, because we're dividing by 6 on both sides. Okay, and solving for b, we're going to do the exact same thing. So we're going to have 6 multiplied by, and we're going to set our other x value in. So that was minus 4. 6 multiplied by minus 4 equals b multiplied by, that would be minus 4 plus 10 plus a multiplied by minus 4 plus 4. And let's solve this. We're going to have 6 times minus 4 minus 24 equals minus 4 plus 10 so that's going to be 6b, and a, as you can see, is going to go to 0. Solving for b, divide by 6 on both sides. b is going to be equal to 4. And we solve for a, it's going to be equal to 10. Okay, so now we've solved for both our values. Let's make the equivalent fraction so that we can integrate. So again, go back up your working. Okay, now I've got our fraction that we originally had, so let's substitute our a and b values in that we have just solved. So we're going to have 10 divided by x plus 10 plus b divided by x plus 4 with respect to x. And also remember that we were doing this with the limits 5 and 1. But let's just integrate this first. Okay, let's go. So we can say f of x, integral is going to be equal to 10 natural log of x plus 10 plus b, so we need to add b in, that was 4 plus 4 times the natural log of x plus 4, and plus c. So let's substitute our boundaries in and solve. So remember, when working with definite integrals, you have your first integral, same equation. You have your higher x value in there, substitute it in, and then you take away the lower x value in the same equation. So that's going to be 10 ln, and we were doing this with 5 and 1. 10 times natural log of 5 plus 10 plus 4 natural log of 5 plus 4. And take away a lower bound, 10 ln 1 plus 10 plus 4 times the natural log of, it'll be 1 plus 4. And I'll put that in the calculator and come back with the answer. Alright, so I got our answer. That is approximately 5.453 units squared. And you could leave that in exact value if you wanted to with all your log functions, but leave it like that and So that's integration by partial fractions, and I hope you enjoyed the video. Always remember that God loves you, and I'll see you in the next video. Bye.